Hey, welcome guys for day 3 of our IELTS live learning. Let's see where we left it from yesterday. We were at section 3. Let's continue from there.
Hi there. We're going to go ahead and proceed with another example of doing section 3 of the IELTS listening exam. Now, this one is really interesting because we have 3 different question types. We have a fill the blank question. So much for taking this course. We're now going to go ahead and get into another analysis of section 3 of the IELTS listening exam. So this one is coming from book number 7, and it's test 3, section 3 from book number 7. As you know, I use books 7 to 14 when teaching this course. I like to give a mixture because there's some question types that you only will see in the older books, 7, 8, 9, and 10, and those question types actually appear on the real exam. And so you want to be aware of every different type of question that you might see on the IELTS listening exam. So now we're in book number 7, and we're test 3, section 3. So let's go ahead and get started. Now, first of all, we have a fill the blank question. And with fill the blank questions, we always want to be aware of the language that is before and after the blank line. So for 21, I'm listening for language that means the same as shaped like. From 22, I'm trying to hear about where the scientists are from. I'm listening for that language. Now, this one is interesting because what we're dealing with here with this one is that we have a diagram in section 3. And most of the time you'll see a diagram in section 2, but that's not the same as what you have right here. This is just a diagram. In section 2, they have a map where you have to follow it. But here it's still a fill the blank question, but they're just presenting it within a diagram format. And so it's very similar to the diagram question that you see for the IELTS reading test. It's the same principle. It's a fill the blank question within a diagram. But for number 23, we're going to be listening for if the float dropped into the ocean and blank by satellite. I'm listening for that language. Something happened by satellite. 24, we're listening for the average distance. I can already predict they're probably going to give us more than one number. Whenever you're dealing with an answer or a question that requires a number, you can expect them to give you more than one number. Number 25 is going to come after they mention something about the salinity of the water or changes in salinity of the water. And then we close it out by a multiple choice question where you have to choose the correct answer choice from the box. So here we're dealing with at present, in the near future, and long-term future. So we know these questions are going to go in order, and they're going to give us synonyms for the correct answer choice. So when they talk about understanding El Nino, they're not going to say exactly at present or in the near future or long-term future. They're going to paraphrase the correct answer choice of A, B, or C. All right, so let's go ahead and get started. I'm going to go ahead and do my test right now. You should go ahead and pull out your book number 7 and do your test on your own, and then you can come back and check your answers against mine. But I'm going to go ahead and do my test right now, and you can see me go through my answering process And I'll go ahead also and point out for you the tricks and traps that they're doing on the exam to try to disguise when the answer is being said. So let's get started.
Thanks to all of you for coming along today to hear about how the Robotic Float project is helping with ocean research. Well, first of all, we'll look at what a robotic float does and its use. So let's start with the device itself. It looks a bit like a cigar, and it's about 1.5 meters long. More importantly, it's full of equipment that's designed to collect data. So it can help us in building up a profile of different factors which work together within the world's oceans.
Sounds like a big project. Isn't it too big for one country to undertake?
That's quite true, but this project is a really good example of international cooperation. Over the last 5 years, scientists from 13 countries have been taking part in the project and launching floats in their area of ocean control. And next year, this number will rise to 14 when Indonesia joins the project.
That's impressive.
But let's move on to how floats work. The operational cycle goes like this. Each of the floats is dropped in the ocean from a boat at a set point and activated from a satellite. Then the float immediately sinks about 2,000 meters. That's 2 whole kilometers down in the water. It stays at this depth for about 10 days and is carried around by the currents which operate in the ocean at this level. During this time, it's possible for it to cover quite large distances, but the average is 50 kilometers.
So, what is it actually recording?
Well, at this stage, nothing. But as it rises to the surface, it collects all sorts of data. Most importantly, variations in salinity, that's salt levels, and the changes in temperature, a bit like underwater weather balloons. Then, when it gets back to the surface, all the data it's collected is beamed up to the satellite. After about 5 hours on the surface, the float automatically sinks, beginning the whole process again.
What happens to the data?
Well, the information is transferred direct to onshore meteorological stations, like our one in Hobart, and within 4 hours the findings can be on computers, and they can be mapped and analysed.
Before you hear the rest of the seminar,